Thank you for the introduction. My talk today will be about understanding iOS-based crowdturfing through hidden UI analysis. This work was done in collaboration with Indiana University and Peking University. While we use our phone or computers, we meet a lot of fake information. Fake reviews, fake news, fake accounts, fake app reviews are good examples. Such fake information are propagated through a model called crowdturfing. Crowdturfing is basically malicious crowdsourcing. It is an illicit business model in which cyber criminals recruit small-time workers to carry out malicious tasks for dishonest third parties. In other words, they just hire a large number of users to perform malicious tasks online. Crowdturfing is supported by a crowdturfing platform, which consists of a server and a client, as shown in the figure. As mentioned, cyber criminals takes requests from the dishonest third parties and pushes tasks to clients, which is further executed by small-time workers. Prior research have studied web-based crowdturfing, which only utilizes desktop clients. However, we are the first to study mobile client-based crowdturfing to the best of our knowledge. Mobile crowdturfing is becoming more important as mobile usage is on the rise. According to recent reports, 58% of network visits are from mobile devices in 2018. While web-based crowdturfing platforms are simply hosted on websites, mobile crowdturfing requires an app to be installed in the user's device. To successfully accomplish the malicious tasks, it is very important for the cyber criminals to reach a large number of underground workers. However, such crowdturfing apps are banned from popular app stores such as Google Play or Apple App Store. Once they're reported, they're immediately removed from the App Store. In this research, we found crowdturfing apps that still infiltrate the App Store. They basically hide the crowdturfing UI behind a benign-looking like app during the app review process. The screenshot in the slide is a good example. It is a typical crowdturfing app. Left side is a word game UI. The first is the game list, and the second is the actual game UI. The app description only mentions the word game. The right side is a crowdturfing UI. It is a list of tasks that can be performed by the user. It is only shown under when specific conditions are met. The goal of this project is to first develop a triage methodology to identify crowdturfing apps. Secondly, we also aim to provide new understanding on mobile crowdturfing ecosystem. As we just saw, crowdturfing UI are hidden inside benign apps and only get triggered when specific conditions are met. Even when they show up, their functionality are very similar to benign apps. They don't download any malware, they don't download any malicious payload, they don't use any sensitive API or private API. This makes it very difficult to use traditional signature-based methodology to detect them. A simple approach is to let human actually look at the content and decide whether if it's related to crowdturfing. However, that is not feasible during the app vetting process. Because of that, we built our detection approach based on the two key ideas. We make use of the fact that crowdturfing UI are conditionally triggered and are semantically related to crowdturfing. Let's take a closer look with an example. Left side is a code that we got from a real crowdturfing app, and the right side is a labeled view controller graph that we used to analyze the UI transitioning of the app. As you can see in the first green box, the app, when it receives a scheme, after parsing it, it'll decide what value it should set to a certain variable. And when the app is opened, depending on what type of value is set to the variable, it'll trigger either the Crowdturfing UI or the benign UI. And as you can see, the first set of keywords extracted from the Crowdturfing UI is obviously related to crowdturfing: task, cash, earn, withdrawal, join, pay, reward. The second set of keywords, album, singer, shuffle, song, music, radio, is obviously related to music player. More details about the labeled view control graph can be found in our paper. Using such observation, we came up with our detection tool Cruiser, which consists of a structure miner and a semantic analyzer. The structure miner takes an app downloaded from the App Store as an input, disassembles it, and analyzes its UI transitioning using the labeled view controller graph that I just shown. After analyzing the labeled view controller graph, it'll come up with a set of suspicious UI. When we say suspicious UI, we mean potential crowdturfing UI. Once the suspicious UI are given, the semantic analyzer will analyze the semantics of the suspicious UI to confirm whether if it's a crowdturfing UI or not. The structure miner is built based on the fact that the set of crowdturfing UI are totally different from the set of benign UI. We search for apps that have more than one entry UIs. If there are more than one entry UI, the main UI can be changed based on certain conditions. We also look for UIs that are not triggered by users. Intermediate UIs that are triggered by certain conditions, for example, a URL scheme, are considered a suspicious UI. Let's take a look at the semantic analyzer. Given the suspicious UI as an input, the semantic analyzer focuses on deciding whether the suspicious UI are indeed crowdturfing UI by doing a simple similarity check. For that purpose, we extract the keywords from the suspicious UI set that we received from the structure miner. We apply clustering algorithms, purifying techniques, and finally apply word2vec to change it to vector space for similarity check. On the other side, to get the keyword set of crowdturfing, we crawled the keywords from popular crowdturfing websites, also applied topping modeling algorithms and did purification, and then applied word2vec. Then, after having the vectors of both sides, we did a simple similarity check using cosine distance. Using those approaches, we confirm whether if it's crowdturfing UI or not. To evaluate the Cruiser, we used the good set and the bad set for deciding the similarity threshold, and then applied Cruiser on the unknown set, which is 28K apps. From the 28K apps, 102 apps were reported, and 93 apps were actual crowdturfing apps. All 93 apps were removed from the App Store immediately after we reported them. So far, I explained what crowdturfing is and how we detected them. Now we'll be looking at the measurement study. We first will look at the crowdturfing value chain discovered in our research. As mentioned before, there are three parties: the dishonest third parties, which request the malicious tasks, such as app ranking manipulation, and there's the cyber criminal, the crowdturfing platform owner, and the workers who actually execute the tasks. Before going to the details, there are the red lines. It's going to be meaning the money flow. The blue lines are going to be meaning the mobile crowdturfing flow. And the third black line is going to be explaining the hidden UI development. Besides the three major components, there are more components such as the mobile device used by the workers, the triggering website, the promotion channel, the crowdturfing app developer, and the App Store. To establish the crowdturfing platform, the cyber criminal will first request the app to a crowdturfing app developer. Once the crowdturfing app is developed, they'll return the app to the cyber criminal and upload the app to the App Store. And once the app gets published, the cyber criminal will be paid. Once the app is published in the App Store, the cyber criminal will start to promote the app through multiple promotion channels, such as online communities, social networks, or app gateway sites, which I will explain later. The workers, the users who are interested in earning money through crowdturfing, will then visit the promotion channels and install the app from the App Store to their device and visit the triggering website and turn their crowdturfing app into the actual crowdturfing UI, because initially it's going to be showing only the benign UI. Once the crowdturfing platform is there, the cybercriminal will start to take requests from the dishonest third party. In this example, he's asking the cybercriminal to manipulate the app ranking. And the cybercriminal will push the task to the mobile client. The workers will execute the task, basically install the app and leave review. Once the tasks are verified, the cybercriminal will pay the workers. This is a quick summary of our findings. The newly discovered 93 apps were related to 67 crowdturfing platforms. Among the 93 apps, 6 apps were in the top 20 of the Apple App Store and across different countries. 14 apps were once ranked in the top 50, and 25 apps were in the top 100 of their corresponding categories. The crowdturfing apps we discovered were found from 15 categories. The top 5 categories are music, utilities, lifestyle, entertainment, and games. While it was found across 15 app categories, most of them come from the top 5. We think it's because the crowdturfing app developers they do not want to spend much time on developing the benign part of the app. So they basically make use of open source projects or template apps found from GitHub or blogs, I guess. To understand how crowdturfing platform owners spread such apps and recruit workers, we searched the app names that we discovered in our research on Google search engine. Through that approach, we discovered 50 channels that advertise crowdturfing apps. Most of them are, as I mentioned before, online communities, social networks, and gateway sites. Gateway sites are basically a crowdturfing app aggregation website, but it's not a complete list. And if you're interested, please let me know. I can talk about it in the break time. Also, based on the number of downloads recorded in the crowdturfing gateway websites, we found that the crowdturfing apps were downloaded more than 32.4 million times. Also, 23% of the apps discovered include an in-app referral feature. The user is paid for referring the crowdturfing app to other users. The following are the top 6 crowdturfing tasks found in our research. As we can see here, while most of them are similar to web-based crowdturfing, the first one, app ranking manipulation, is included in most mobile client apps. This makes sense because app ranking manipulation can only be done through a mobile client, because the app actually needs to be installed in the phone, and sometimes they request them to even leave a review. Also, while most have few updates, still a large portion of them were reaching a high version number. This is interesting because every time they submit a new version, they need to go through the review process again. This means that Apple does not have a systematic way to detect such apps yet. To measure the task volume of the app, we crawled 5 apps' task information manually and the number of required workers through their crowdturfing UIs. By multiplying the daily task volume to the per task price, we can get a number of $5,889. So the lower bound of the crowdturfing platform owner, the cybercriminal, will be $5,889. We also studied how such apps were hiding their UI. Let's begin with how they are developed. By searching Google with the app names, we found that the crowdturfing platform owners, the cybercriminals, were willing to pay up to $450 for getting an illicit app that is capable of hiding the crowdturfing UI to pass the app review process. Crowdturfing apps were often built based on an open source project, as mentioned before. Such templates can be found in blogs or GitHub. Interestingly, 6 apps were based on the same music player template. And there are some other findings that I'll just shortly mention due to time limit. We also study the triggers. Like the UI was triggered based on logic bumps, C2 servers, schemes. Many apps were resubmitted only after changing their bundle ID under a different developer ID. Also, crowdturfing platforms own multiple crowdturfing apps. For more details, please read the paper. Takeaways. We tried to provide new understanding on mobile crowdturfing ecosystem. We also provide new techniques based on hidden UI for evading Apple's app vetting. Thank you.
Okay, thank you, Yeonjoon, for fascinating work. Please step up, ask questions. State your name and affiliation, Anatoly.
Hi, I'm Anatoly, Ben Gurion University, Israel.
Pardon me, can you speak louder, please?
Oh, I'm Anatoly, Ben Gurion University, Israel. Thank you for the talk. I was wondering, you had mentioned 9 apps that you were figured out that they're false positive out 102. This is a huge number for malicious, for wrong identification. Have you tried to analyze why is that considered such a crowdturfing applications?
So one reason why we call that tool a triage methodology is because of the false detection rate instead of a detection tool. And the false positives were also a lot of them were related to malicious activities. They were not hiding crowdturfing functions, but they were hiding phishing UI, or they were hiding some other malicious activities that are currently under work in our follow-up work, actually. So those false positives are not related to crowdturfing, but it's still related to some malicious activities.
So you actually don't search for the...
It's an undergoing work, and
okay. Thank you very much.
We'll probably submit it soon. Yeah.
Hello, I'm Stephen Sheffy from Middle Tennessee State University. You mentioned that the apps don't use any sort of private APIs. Is that indicating they're not communicating with some sort of central control server from the crowdturfing people? Or is it that like these tasks are embedded in app updates, which may explain the high update frequency?
So I think I didn't understand your question clearly because it was a little bit not loud enough.
Oh, sorry. You mentioned that they do not use private APIs.
Right, private API.
Does that mean that they're not submitting tasks to a private API server that they own?
Oh, no. I'm talking about the private API and the sensitive APIs that are used by malicious apps in Android or iOS. Because in malware research, when we talk about private API and sensitive API, it's usually APIs that access sensitive data in the phone, like, for example, like the contacts or the location or etc.
Okay, thank you.
Mm-hmm. Okay, so let's thank all our speakers, Anne, Fabio, Yi, and Yeonjoon. Thanks again.